Hello. In this video, we're just going to look at the introduction to investigating and comparing data distributions. So we're only really looking at univariate data. So when you think of the word univariate, and I might write that down for you. So uni meaning one. Okay, so think of a unicycle, and variate meaning variable. So we're only looking at one variable data. In the next time we do stats, we're going to be looking at bivariate data. So when you think of bi, it's two, like bicycle, and then variate, two variables. Okay, but in chapter 2, bivariate, let me just get rid of that. Okay, so 1, 2. But in chapter 2, we're only looking at univariate data. The objectives of this area of study are listed there. I'm not going to read them because I'm sure you can read, but this is just a brief introduction. So this will be just a short video just to introduce the topic. Okay, so math, the only place where people buy 64 watermelons and no one wonders why. Well, I think with the way things are at the moment, buying 64 watermelons might not be a weird thing, or maybe it will be, although who knows. All right, let's look now at the different types of data. So there are different, you can collect so many pieces of data, but you need to kind of categorize them. So let's think about if we were to go around the class and ask each student their height. So there's different ways we can actually measure height. The one that you're probably thinking about now is measuring using a measuring tape. So you're going to measure in, say, centimeters. If you're looking at that sort of data, that would be different to if you were to categorize the students as either short, tall, or medium height. Okay, so even though we're measuring height for both ones, the type of data does differ, and that's what this chapter is going to look at. So we would expect to get quite a variety of answers. In this context, the characteristic height is called a variable because its value is not always the same. So when you think about my height, and I'm quite tall, it's very different to maybe a year 7's height who is quite short. So we're not all the same height. And there's all different types of variables. So if we look at the following 4 different situations, you can get students to answer, and we're not, you just don't have students doing this. This is just the example. You can just have anyone in the general population. So students answer a question by selecting yes, no, or I don't know. So you could say, do you do year 11 general maths? Yes, no, or don't know. Hopefully you would know if you were doing year 11 general maths. But anyway, students say how they feel about a particular statement by ticking one of strongly agree, no opinion, disagree, or strongly disagree. So maybe you're asking them, do you like year 11 general maths? And obviously everyone would say strongly agree. Students write down the number of brothers they have. So I have 2 brothers. You might have 1 brother, or no brothers, or 3 brothers. And then the last one, students write down their height. So I'm 180 centimeters, you might be 165 centimeters, someone else might be 190 centimeters. Okay, so that's another type of data. These situations can give rise to 2 different broad classifications of data. So basically, when we're talking about data, we have 2 key ones, so categorical and numerical. Okay, so categorical usually means we can put the data into categories. So when you think about maybe eye color, can be categorized as either being blue, brown, green, gray. So you're having categories there. You're not actually, you can't measure it in any way. And that's the main difference. Numerical data can be measured, but it can also be counted. So any data that can be measured, so height can be measured in centimeters, weight can be measured in kilograms or grams. You can measure time in seconds, or you can count numerical data. So how many people in the class wear sunglasses, wear glasses, how many people have a sister at home, or how many people have a dog, okay, those sorts of things. Now, one key thing that you need to remember is that numerical data isn't always data with numbers. Actually, sorry, I should rephrase that. Data with numbers isn't always numerical data. Okay, so numerical data will always be numbers, but data containing numbers isn't always numerical data. And the key example of that is postcodes. So postcodes, when you think about it, we're not measuring postcodes, nor are we counting postcodes. So postcodes, even though they have a number, so I live in 3195 Mordialloc, it's not numerical data because it can't be measured. Okay, we don't measure postcodes in any way, and we don't count them. We can count the number of people who live within the postcode, but that's not, the postcode itself is not numerical. Another one could be a house number. Okay, so house numbers can't be measured and can't be counted. Okay, so when you come down, and I'll just scroll down to here, it's a good idea to have an example for each one, okay, because it just gets you thinking, and maybe it's easier to distinguish between the two. So this little diagram here is fantastic to have in your bound reference, but there's no examples. Okay, there's explanation here, but I would add numerical data. Okay, so that's my pen. Okay, so it can be, whoops, actually, what am I doing? It's already done down here. Okay, discrete data just means it can be counted. And continuous data is measured. Okay, so discrete, so an example of that would be number of pets. And oh gosh, sorry, that says number of pets. I'm just trying to do it quickly. And then continuous can be height in, and you're always going to say what you're measuring in. So height in centimeters. Okay, if you were doing height, say, and I might do that over here, okay, because you can also have height in categories. Height measured, oops, let's put the T. You can have tall, sorry, average, it's a G, and short. Okay, so even though we've got height here and height here, if you're measuring it in centimeters, it's continuous, but if it's measured using a category, so tall, average, short, it's categorical. And this is ordinal data because the categories are put in some order. Okay, so we've got short, average, tall. You might have also very tall or very short. And nominal is just the eye color example. Okay, so eye color. Okay, so obviously we can't put that in any order. We can't measure eye color and we can't count eye color. So it is blue, brown, what else do we have? I don't put the comma there, green, etc. Okay, I don't want to take too long, but it's a good idea to have those examples in your bound reference. Okay, so that's all for 2A. I'm going to leave it there, but make sure you have this diagram in your bound reference because it's always good to go back if you get confused by the definitions. All right, bye.